Hello everyone, and welcome to the NEATEC Electronics Series. This episode is about parity, so let's get started. Alright everybody, let's talk about parity. Parity is a method that is used to check the transmission of data. Okay? It really is used to check what was transmitted is what was received. Okay? So there are two types of parity. It's called even, right, and odd. Now, I'm going to show you an example parity number here. So imagine you have 7, 2, 3, 4, 5, 6, 7. Suppose this is what was sent. 0, 1, 1, 0, 0, 0, 1. Now you notice there's 7 here, right? This is your data that's being sent. We have one additional bit at the end. This is your parity bit. Okay? This is appended to the end of the digital number that you're sending. Okay? Now, here's the thing that I want to make sure that you get. Okay? So if you count the number of ones, in this case we have 1, 2, 3 ones. There's 3 ones in that number. And suppose you had an agreement between the transmitter and the receiver that you're going to use even parity. Okay? Now let me define even parity. Even parity means the number of ones, right? Number of ones is 0 or even. Okay? So if we look at this, we have an odd number of ones, don't we? We have 1, 2, 3 ones. So in order for this to be even parity, we would have to make this bit here 1. Because if you do that, these 8 bits would have 4 ones in them, right? Because you just added a 1 there, and it would be even parity. Get it? Now, if on the other hand the transmitter and the receiver wish to use odd parity, then the number of ones is odd. In that case, you have 3 ones in this 7 bits, right? So this 8th bit would simply be a 0 because the number of ones is already odd. So you don't have to add another 1 to it, so you would make it a 0. Alright? So I wrote this exclusive OR gate over here. Actually, I should say I drew an exclusive OR gate over here to show how we're going to write the circuit to check for this. But let's talk a little bit more about parity and generating parity. Okay? Let's try another example here, shall we? So in this second example, I'm going to write down 7 bits again. And I'm going to ask you to fill in the parity bit, all right? This is the parity bit right here. Now, let me write this number down for you. Let's try 0, 0, 1, 0, 0, 0, 0. Now, if we have an agreement and we want to use even parity, and let's just write this down. If we're going to use even parity, what's going to be your parity bit? And if we're going to use odd parity, what's going to be your parity bit? So why don't you pause the video, give it a go, and turn it back on, and we'll do it together. Alright, well first let's count the number of ones in this string of 7 bits. Well, we only have 1, right? So we have an odd number of ones. So obviously, if we want to use even parity, we need an even number of ones. We would have to add a 1 here. So even, you would have a 1, right? Now, if we had agreed to use odd parity, we wouldn't be putting a 1 there, would we? This would simply be 0. Because you already have an odd number of ones, right? You only have 1 1. Got it? Alright, let's try another one real quick. Let's change that one, right? What the heck? Now, I'm going to erase this. I'll erase this for you. I'll erase this for you. Alright everyone, pause the video, and I want you to try to determine what that parity bit would be if you're going to use even parity or odd parity. Then turn it back on and we'll do it together. Alright, welcome back. So how many ones do we have in this 7-bit string? 7 bits of data here. We have a 1 here and we have a 1 here. So we have 2 ones, right? So if this is going to be even parity, we just put a 0 here because we already have an even number of ones, right? 2 of them. If, on the other hand, we want to make it odd, use odd parity, we would have to add a 1 here, wouldn't we? Because then we would have 3 ones, which is odd, so your odd parity bit would be a 1. You get it? Alright, I think you understand how that works. It's really not too bad, right? So let's talk about the generation of the parity bit. See you shortly. Alright, so let's talk about the circuit used to generate the parity bit, okay? So I've drawn a 4-bit generator over here on the left, okay? So if you notice, we have 4 bits, A, B, C, D. And I'm just going to draw them right here for you. This is A, B, C, D. And we have, instead of 7 bits, we just have 4. And I just did that in terms of space, okay? But let's continue here. So if this is A, this is B, this is C, and this is D, and right there, that's your parity bit. Now, you need to generate a parity bit for either odd parity or even parity. Well, let's look what happens. Let's just do an example. Sometimes the best way to solve these problems is draw the circuit, and if you know what the input is, you know what the output should be, you can test it, right? So if you look at that, you have 2 ones, right? This is a 1, this is a 1, this is a 0, and this is a 0. Well, what is the output going to be here? You have a 1 and a 1 going in here. Well, check here. A 1, 1 would result in a 0, right? So you would have a 0 being output here. And a 0, 0 coming in, well, that would be another 0 right here, right? So a 0, 0 coming into this one, if this is 0 and this is 0, again, we look right here, it would output a 0, right? Now, this circuit, as we have right here, if this is the parity bit right here, it would generate a 0 there. So that would generate even parity, wouldn't it? Because this bit would come out to be a 0, and 0, a parity bit of 0, that would mean you're using even parity, right? Suppose you wanted to use odd parity. How would you do it? Well, we could simply add another exclusive OR gate here, right? And we could go to a switch here, right? And we could say, if we want to use even parity, we use a bar, we want to keep it low, right? Or if we want to use odd parity, it would be high. So, keeping with our question, this is just a slash, that's all it is. That's just to divide the two words, even and odd. So if we're going to use odd parity, that means this would be a 1, wouldn't it? A 0 and a 1 coming in here. Well, here you go. It's going to be one of these two, right? And that would result in a 1 being output. So your parity bit could then be changed to a 1. All right? Now, the thing is, once you generate the parity bit and you transmit it, you're going to receive it, right? The receiver has to go through the exact same method to generate a parity bit from these 4 bits, and then check the parity bit that it generated with the parity bit that was sent, okay? So to do that part, I'm just going to put a little box around here for you just so you guys get it. This here, what I'm taking a box around, this here is your generator. Got it? Now let's take this out, and now we're going to check it. Alright? So this is your parity bit that was sent. So let's just say now you're looking at the receiver side. If you get a parity bit that was sent, you're going to compare that parity bit to what you just generated. Okay? What are you going to do with that? Simply put it into another exclusive OR gate. Alright? Now, if those are the same, your output will be a 0, won't it? Because you're going to be in either one of these two cases here. Right? If it's a 1, it's bad. So to check it, alright, if this is your, I'm going to call it P prime, if P prime equals 0, you're okay. You're good. Alright? You're good. I'm going to put a good here too. Alright? If P prime equals a 1, that's bad. And you would have to resend the information. Okay? One last thing I want to leave you with regarding parity, okay? Parity is not perfect. And why don't I just take a little space over here for you just to show this to you. What you're checking here is you're counting the number of 1s. So suppose we have 7 bits here, okay? And suppose they're all 0s. right? And we're using odd parity. So if we're using odd parity, your parity bit would be a 1, right? Because it has to be an odd number, right? Now, suppose 2 bits were flipped in the transmission, and there was some noise on the lines and 2 bits got flipped. So suppose what was received was 0, 1, 0, 1, 0, 0. In other words, this bit flipped and this bit flipped. Well, if the parity bit was a 1, would you still have odd parity? Yes, you would. In other words, it wouldn't catch that. It wouldn't catch those bits flipping. The chances of that are small, but the idea of bits flipping so it is missed by this is small, but it can happen, okay? I just wanted to make sure that we got through that, okay? I'm sure you can convince yourself. Just take whatever number and flip 2 bits. You can make one go high, one go low. You can make 2 go high, and you'll see that it's not a perfect method, okay? But how it's generated and how it's used is using this kind of circuit, okay? A little bit of nostalgia for you. 20 years ago, 30 years ago, we had things called modems. Modems, you used a modem to connect to your phone line, which would, you'd connect your modem to your computer, obviously, and that would sit on top of your computer, okay? And that's how you were able to connect remotely to computers. Now, when you did this, you would have to find out if the computer you're connecting to uses even or odd parity. And on your modem, there was a switch, okay? And the switch is right here. You had to flip that switch to either even or odd, and then you could communicate with it. Usually when you did this, the place you're going to communicate with, either the university or the college or wherever you were communicating with, they would have to mail you, or you would have to talk to someone on the phone to find out what parity was being used and what the settings are. They had baud rates and things like that that you would have to be concerned about. But this was highly used. All right, everyone. I hope this history lesson has been valuable to you, and I'll see you soon.